road. So with that said, these are our three part of our biggest projects is to do applied science to increase situational awareness. We do that by mapping where landslide usually occurs. So with the landslide susceptibility map, I'm going to talk briefly about that, and also about the network that tells us when landslides can occur. So why Puerto Rico? Again, people are very aware, that's a very important part, but also all of the, many of the conditions that are prone to landslides, so steep topography, a tropical climate with very intense precipitation events, intense land use. All of these things are occurring in Puerto Rico. So it's a very good place to do this kind of research. Now, we also have had, and this is another case of the deadliest landslide that have occurred in any U.S. jurisdictions. Puerto Rico, this is Barrio Mayagüez in Ponce, 1985. About 129 people died in this event. It was a tropical depression passing by, left around 22 inches of rain in a day, which, thanks to Pedro for the average rainfall in Colorado is 16 inches for the year. So you can think about just in a single day, and this event occurred. This is a deep-seated landslide. This is not the kind of landslides that I'll be talking about, but this is the kind of landslides that also occur. Now, this is our typical landslides, and this is just an example. You can see it right over here. These are shallow landslides that occur on the soil. Usually, they can expose the bedrock below. Not always, but it typically occurs. And this is a case of Hurricane Maria. I don't know if you're aware of Hurricane Maria. It's a Category 4 hurricane, almost a Category 5 by just few miles per hour rating, but massively devastating event. And it caused a lot of landslides. I'll show you just one example here to put in context of how these events occur. Presentations where it's just a person recording while a landslide was about to occur. You'll see this is during Hurricane Maria. You can see the water pouring down. It's going back. He said it fell. Part of his properties is it's gone. You can see how it took the structure, and when the people, when they left the property, they were lucky that they were not in that too close though. You can see a car in there, lots of water flowing, and you can see back there in the background, you still see the water, the mud, the debris flow continuing. Now, these occur on these very big events, such as Hurricane Maria. I think this is another example of aerial imagery before and after. I'm going to go quickly over here. This is after, before. This is a farm in Utuado. You can see many of the landslide scars. Many of these are occurring landslides. And if you count all of those for all of Puerto Rico, which was what Steve and his group did back in after Hurricane Maria, and in collaboration with the USGS, you get over 70,000 landslides, a single event. With that said, this is also an opportunity to really understand landslide hazards. So thanks to that map, we can develop the high resolution landslide susceptibility map. And this is a great tool for emergency managers and for planners in Puerto Rico to really understand where landslides occur. This is a tool that it's also produced at the municipality level. It's the same map, but more tailored to each municipality. They love it. Emergency managers love to see it, and they also just sort of confirm where the problems they have been dealing with are. So yeah, and also we also produce the landslide guides for residents in Puerto Rico in collaboration with the USGS and Jocelyn West, which was leading that effort. So now the network. This is the Puerto Rico Landslide Forecast Network. This essentially we have 19 stations across the island, across very different kinds of soils. All of them are in very steep topography, so we targeted particularly highly susceptible terrains based on this map. So we wanted to get those really steep slopes and monitor not only rainfall, which was previously the variable used to predict when landslides would occur, or very intense and with long duration events, then you have landslide triggering rainfall. But now we're incorporating soil moisture and piezometer observations, as well as that, just to measure what are the actual soil conditions antecedent to the rainfall events. So these are stations. You can see how this is just a photograph of one of our stations. We don't usually are targeting like open canopy particularly. We're more looking for those very steep terrains. So many of our stations, some of them are in open sky, some of them are under canopy. We're looking at what exactly just is the soil receiving. So we have 4 sensors that go, that's the volumetric water content sensors, as well as suction sensors, and the piezometer all the way at 1 meter. Usually we have it on 25, 50, 75, and 100 centimeters. Which is a little different from your soil observations. We acknowledge, but we're trying to target that interface where slip surfaces occur, and we're trying to targeting landslides, right? So this is a picture of one of our stations with the students. This is after installation, and this is in Adjuntas, Steven doing some maintenance in there. And this is how one of our products looks like. This is our saturation levels based on the highest measured volumetric water content on that particular site. So this is essentially percent saturation percentiles. And I think one of the things that I wanted to share is like a success example. And this is also data from our station, but I want to show you a success example after. But I wanted to show you here. That's Hurricane Fiona right here. You can see the precipitation up here. You can see the volumetric water content responses up there. And this is the piezometer response. During that period, Stephen, he was looking at the data, and he contacted one of his partner, Jimmy, who the instrument in the property. And so he managed to call Jimmy when he saw all of that responses, and he told him that all the conditions are there for landslide occurrence. And Jimmy managed to talk to neighbors to mobilize, and after that, this occurred. So this is just an anecdotal example of how this tool can really work. Usually we're not gonna have Steven looking at the data all the time to call Jimmy or someone else, but what we're looking for is to get this publicly available as soon as possible. So what we're trying to do in each of the stations, we're trying to get these bilinear thresholds between soil saturation and also rainfall, to see in each of the stations what are these thresholds for each of these conditions. And to do this, we're also compiling a landslide database for Puerto Rico. And with that, we're validating whether landslide occurred near the stations and what were the conditions in the stations when those landslides occurred. And with that, that's how we can develop the landslide forecast product. Our landslide forecast product essentially is a 10-kilometer buffer zone, as you can see in the images. What we're trying to do is measure what's our average antecedent condition, soil moisture conditions in our soil moisture sensors, and with what's the 24-hour precipitation forecast for the next day. And with that, we can increase our situational awareness and share it with our partners in the National Weather Service, so they can disseminate information about risk of landslides. And this is just an example of how does it work. This is one of the sites, or one of the days where rainfall was pretty high and the soil saturation was high. So you see areas with very high classification. We have really good partners in the media that also help to disseminate this information. Not the landslide product. The landslide product is not yet out. this is still an experimental phase before we share it publicly, but they have shared the soil moisture data often, and it really helps out to illustrate and inform the public about soil moisture conditions, which is critical to understand for landslide hazards. So this is an example of tropical storm Ernesto. You can see that the forecast, this is the rainfall forecast, and these are the soil saturation levels. And you can see how many of these areas where it's very hot, it's highly saturated, you get very high rainfall, so very high forecast. And usually landslide tend to occur, particularly many of these driven by these intense rainfall events. Now, this is one of the most important part, I think, from our project is Landslide Ready. Landslide Ready is a program, it's a community engagement program, but really it's more engaged, it's a program for the emergency managers at the municipal level. Essentially what we do is we go talk to the emergency managers and we form what we call Landslide Ready delegates, which they are a group of emergency managers that are in decision makers that are in charge of doing preparedness, evaluation, and response. And essentially what they have to do is we do the series of community talks. This is in the stage we're here. Then we do a workshop with them where we share the tools for the landslide susceptibility maps, for the landslide forecast product, and also all the soil saturation and monitoring stations. And after that, they come to our office and they prepare a manual where they have to put also their critical infrastructure in the maps. They have to be more, it's just try to build a spatial sense of where landslides are highly susceptible and when they can occur with the monitoring stations and their current emergency plans. And with that, we can recognize, after we do this series of steps, we can recognize them as landslide ready, like the municipality of Utuado just did a couple months ago. This is the first municipality that is landslide ready. I forgot to mention landslide ready comes from a unashameful copy of Tsunami Ready. I don't know if you're familiar with Tsunami Ready, but it's completely a copy. We even talked to Krista and all the people that are running in the coast of Puerto Rico, because if we think about it, Tsunami Ready essentially is all the municipalities that does not need to be landslide ready. That's what happens with Puerto Rico. So we're like the exact copy. Okay, so with that, thank you. And any questions are welcome. This is you can access all this information in the rupe.net. You can follow that QR code. And you can find all of these. The landslide forecast product is not yet out, but is as soon as it will be out, I'll make sure to share it with you promptly. Thank you.
Questions for Pedro? I can start. So can you go back to the slide just so they want
Absolutely.
grab that,
Yeah.
that QR code.
Yes.
So the resolution, so you have the situ data here. From a remote sensing perspective, can you talk about your challenges with remote sensing, resolution, the scale of your landslides?
Yeah, so many of our landslides can be tens of meters, tens of square meters, or they can be up now down to nuance. Some of them can block roads, and that can be a problem, but they can be small enough so it's hard to detect it with satellite imagery because they're too small essentially. And also when you have also satellite imagery, you can also have clouds, which is a little bit of a challenge to try to find that landslide detection. However, we have a very close-knit, I would say, network of, and we're building it even more with the Landslide Ready program, where emergency managers are starting to text us and send us all information for our database. We're also scraping, trying to find all on social media events of landslides, and we also record them and get their location. And hopefully we'll build a tool so we can have a survey where we can gather data from users in the ground, and they can tell us when landslide occurred, a picture, and get the location. They take the picture. So I think that's the next step. I think we have many next steps. We're a young network. I must say, I've learned a lot from all of your presentations, and we got a lot of work to do, but I think we're heading in the right direction. So.
Other questions? Pedro?
Thanks, Pedro. So really appreciate the soil moisture data. I'm curious to hear more about how you selected locations for your stations and how you decided on, I think you said a 10-kilometer radius around your station.
That's an excellent question. The location is, we want to try to, first of all, have a coverage of the island, right? So the first things that we think about only is like, within the area that we're still missing around some areas, where can we put a station where it's highly in a location that is highly susceptible, already mapped at a 5-meter resolution. So we have a couple places, a place that is very steep and has enough soil that we can put a meter down the soil profile, so we can measure. So that's another parameter. Permits, all the better if it's a state or municipal land, that would be even better. And the decision on the 10-kilometer grid right now is for coverage. So one of the biggest challenges when we go on the Landslide Ready program with the emergency managers is they say, okay, I have a station here in Utuado and then another one in the next town. Which one should I look at? And I was like, oof. Great question. This is a great question because we don't, it's really, we have to really assess what are the soil conditions across the municipality and which station is actually representative of it. Not necessarily because it's closer to you, it's more applicable to where you are. So it's still a tricky question, and we're trying to get there with the help of the USGS. So. Thank you.